fashion. And so that actually is something that was discovered and has long fascinated astronomers, and variable stars have become very important in astronomy. In terms of mythology, Cetus is thought to be the sea monster that captured Andromeda. All right. So, where does Andromeda come into this discussion? Well, her mother was Cassiopeia, a queen, and Cassiopeia is a bright W or M of stars up in the northern sky. Even from a major metropolitan area like San Diego, if you have a good view of the northern sky, you can typically pick out this W of stars. And so Cassiopeia, the queen, was Andromeda's mother. Cepheus, the king, was Andromeda's father. And they boasted that their daughter Andromeda was so beautiful that she was even more beautiful than the daughters of the gods. And so that's where they all fit up together on the sky. Other things to note about Andromeda, if you're out in a really dark sky, which is going to be pretty much impossible to do here in San Diego, but you can get to darker skies like in Ramona or Julian or out in the desert. The Andromeda Galaxy is up in the constellation Andromeda, and it is the most distant object that is visible with the naked eye. It is about 2.5 million light years away. If you remember, a light year is the distance that light travels in a year. And so if you're seeing Andromeda Galaxy up in the sky, you're not seeing it as it is, but you're seeing it as it was 2.5 million years ago. Now, it is visible to the naked eye. That doesn't mean it's easy to see. It's one of these things where you need to kind of know where to look for it, and you need to look with it for it with your averted vision, and it's kind of this little gray ghost up in the sky. But if you're ever out in a really dark sky in the fall going into winter, try to find the Andromeda Galaxy. Up in Andromeda, who was, as we said, she was the daughter of a king and a queen that were so proud of her that they boasted and drew the ire of the gods, which is why they sent Cetus, the sea monster, to capture her. And then she was rescued by Perseus. In Greek mythology, Perseus was the son of Danae, and he is the hero that slayed Medusa, the Gorgon. And then he used the Gorgon's head later to help rescue Andromeda from the monster Cetus. And when he cut off the Gorgon's head, the winged horse Pegasus flew out from her body. All right. So I know it gets kind of gory. I know. If you wanted to look for Pegasus up in the sky, you see that big square. We often refer to that as the Great Square in Pegasus, because those are four stars that make a very definite square up on the sky, and they're reasonably bright, and so that even from a metropolitan area, you have a chance of seeing those stars when you take up a look up in the sky. Um, and I wanted to show you all of this together. So the king, the queen, their daughter, the sea monster that captured her, the hero, and his winged horse that rescued her. When we talk about constellations, we say that constellations represent myths and they tell stories. But here's a case where these separate constellations all join together and tell a single coherent story. And it takes up most of the sky overhead tonight. If you go outside at around 8 to 8:30 and you have a clear sky and you look up, this is the story above you on the sky. Now let's take a look at some other constellations up in the sky. And I wanted to mention one that you may not have heard of, which is Camelopardalis. There is a giraffe up in the sky. The name comes from two Greek terms for camel for a long neck, leopard with spots. You put it together, you get Camelopardalis for a giraffe. And this constellation that was introduced in the early 1600s. Um, a lot of the constellations that are still in use today were cataloged by the Greek astronomer Ptolemy about 2,000 years ago. And so some of these constellations and their myths are ancient, but what he did was he came up with 48 constellations in the northern hemisphere sky, and he connected the brightest dots. But astronomers don't use constellations to tell stories. We use constellations to help give position on the sky. And so, what in the 16th and 17th centuries, there were efforts to start connecting some of the fainter dots and filling in some of the gaps between the brighter constellations. And so, although Camelopardalis turns out to be the 18th largest of all the modern constellations that astronomers use, it's not particularly bright, and you would probably have a hard time finding it up in tonight's sky. But if you can find Cassiopeia, you know that up there somewhere is a giraffe next to her in the sky. Another constellation that's visible up in the northern sky tonight is Auriga, the charioteer. Its brightest star is called Capella, and it is about 42 light years from our solar system. So contrast that with Andromeda Galaxy being 2.5 million light years away. But that still means tonight when you go outside and you see this particularly bright star, because it is one of the brighter stars in the sky, you're still not seeing it as it is, but rather as it was about 42 years ago. And let's go from Auriga, which has a bright star, to a constellation in the southern sky. And one of the reasons why I love this one is that you can see that it actually did connect a lot of the fainter dots to fill up a huge, huge region of the sky. This is Eridanus, the river, and it is the sixth largest of the constellations that astronomers use. Um, and its brightest star is named Achernar, which means the river's end, which is kind of a poetic name for the star. And what I love about it is that, yeah, you can see it's like, oh, look, there's a bunch of faint stars in this area. We're just going to connect them in this meandering path like a river. It is named after the Po River, actually. And then if you're a science fiction nerd, like so many of us are, the planet Vulcan is supposed to be orbiting a star in the constellation Eridanus. So I always feel like I have to mention that. There is a really faint constellation, one of the ones that we consider to be a modern constellation because it was first cataloged in the 16th century, or actually in the mid 1700s. And this is Fornax, the furnace. There are no particularly bright stars in here. Like if you and I were to go outside tonight and try to look for it, we'd probably be out of luck. But I like mentioning this because some of you are familiar with the Hubble Deep Field images. One of the famous Hubble Deep Field images was taken in this part of the sky. And basically, if you take a look at this region of the sky in Fornax, a bit about the size of the full moon, you can't see any stars in that region with the naked eye. But when you take a look at it with the Hubble Space Telescope for a long time, you see thousands of galaxies. And so it's a reminder that there is stuff hidden up there between the bright dots in the sky. And then rising over in the east tonight is Orion, the hunter. Orion is a winter constellation. So when I see it rising in the early evening, I know we're definitely heading into winter. And it is one of the most popular constellations. People tend to find it easy to pick out due to the three bright stars that make up Orion's belt, kind of looking like triplets up in the sky. It's bright star Rigel is the blue star, and the in its right in Orion's right foot, as seen from here, is about seven is over 700 light years away. The red star marking his left shoulder from our point of view is Betelgeuse, and it's about a little over 400 light years away. And that's the one that changed its brightness greatly a few years ago. And we were really hoping it was going to explode and go supernova, and it hasn't done it yet. And I really hope it would just blow up. Because even if it didn't happen at a time of year when Orion is visible at night, a supernova that happened only 400 light years away would be visible during the day. And also, it'd just be really cool to see a star that close blow up. So we can hope. All right. And then let's take a look at some other constellations that you may have heard of. Starting over in the southwestern part of the sky, Capricornus is the sea goat. and it is setting over there in the southwest. You might notice that there is a bright dot near the capital letter C there that isn't part of the constellation. It looks like here its dot didn't get connected. Turns out that's Jupiter. We'll talk more about that in a few minutes. Oops. And then as we continue going from west to east across the sky, the next constellation I want to mention is Aquarius, which is the water carrier or the cup carrier. Um, Despite its prominent position on the sky, how big it doesn't have particularly bright stars. But its myth associated with the water carrier, the cup carrier, comes from ancient Egyptian astronomy. The idea being that when Aquarius would dip the water into the river Nile, the Nile would overflow its banks. And so you could actually predict the annual flooding of the Nile by knowing where Aquarius was in the sky. Let's continue going to the east. We have Pisces, the fish. Two usually shown as two fish connected together by a cord. The brightest star in Pisces is the one down at the base of the V, which is the base of that cord, and its name is Alresha, and it is located about 140 light years from our solar system. Let's continue going east across the sky. We have Aries, the ram. Um, to our eyes up in the sky, we would pretty much, in a large metropolitan area like San Diego, we're pretty much only seeing like two bright stars in a line here. Um, it is the brightest star, and it is named Hamal, which comes from an Arabic term that means the head of the ram, and it's located, about 66 or so light years away from us. And I don't really see a ram there. And so if you don't see it, you have my sympathy. And then the next constellation I want to mention over to the east is Taurus, the bull. And this one actually, even in a large metropolitan area like San Diego, you can pick out the V of the bull, which is under the T in Taurus here tonight. To the left of the T, you see this bright red star. It's named Aldebaran. Its name comes from an Arabic term that means follower because it's following the rest of the stars in Taurus across the sky. And it's located about 65 light years away from us. And it's one of those red giants, which means, yes, it means it's a big red star, but that means it's really big. Like if you were to put it in our solar system, the inner planets like Mercury and Venus would likely be inside of it based on its size. So it can be quite large. And then the constellation that I wanted to mention last, which is rising over in the east to the north of Orion around 8 o'clock tonight, is Gemini, the twins. The names of the two brightest stars, only the one of them is showing up, rising at this point tonight. They're named Castor and Pollux, and they're after twins from Roman mythology. But one of the things that I find interesting in this part of the sky is that those two stars were considered to be twins in several mythologies, including in Babylonian astronomy, which predates Roman astronomy. This area of the sky was called the Great Twins. And so we actually see different cultures looking up at the sky and seeing similar patterns. And this last set of constellations that I've talked about, I bet you heard of them. And you've heard of them as a group called the signs of the zodiac. And so you might be wondering, why are these constellations important? Well, you'll notice that they make a line across the sky. And if we fit a line through it, you may notice that that line has months and days of the year basically on it. This is called the ecliptic. It's the path of the sun across the sky. And what you're seeing here with the months is you're seeing what constellation the sun is in on that day of the year. So because the sun set a little bit before, sunset was a little bit before 5 tonight, and we're in December, December is well below the western horizon on this image. Now, I said that the ecliptic was the path of the sun on the sky, and That's true. The sun itself, from our point of view, so basically, as we revolve around the sun, these are the constellations we see the sun in from our point of view. But you might notice there are some other objects hanging out around the ecliptic tonight. Saturn, Jupiter, Neptune, and Uranus are all along the ecliptic tonight as well. So the ecliptic also is the path of the planets as well. And that gives you the idea that our solar system actually is kind of a disc-like shape, and the planets all orbit on what we call the same rough orbital plane. And so we make sort of a disk of planets orbiting the sun, and that's what we're seeing up here. Jupiter and Saturn are both in the constellation Capricornus tonight. And I wanted to show you some recent images of Jupiter and Saturn. These are both Hubble Space Telescope images, actually. Every year, the Hubble Space Telescope, instead of, it focuses on some of the planets in our own solar system to take images. And so here we have an image of Jupiter on the left that was taken in September, showing sort of the really sort of interesting colors that are going on Jupiter right now. There is a band of red that is pretty deeply red right now, and it's sort of remained that sort of deepish reddish color longer than most previous darkening episodes or so that we talk about them. So Jupiter is striped, and those stripes maintain a fairly stable set of latitudes. We do not see north-south mixing on Jupiter, and it's due to a very highly stable wind pattern. But we do see some changes in coloration as a mixing of some of the atmospheric clouds from below get mixed up into higher uh, altitudes and then dipping back down. We've got some reddish storms up there that are kind of reddish brownish storms. And then, of course, we've got the great red spot. And there's some really interesting fluid flow going around it right now, which I just find really interesting. I can't remember seeing the great red spot looking quite like that. To give you a sense of size, Jupiter is the largest planet in our solar system, and that great red spot, you can fit a couple of Earths in it easily. And so it's big. And then we have Saturn on the right. This is a look at Saturn as it was in September from the Hubble Space Telescope. And you're also seeing some stripes. Now, Saturn and Jupiter both have these stripes. On Saturn, their colors are a little bit more subtle. And so think of this image as being true color, but with the contrast cranked up a bit so you could see more of the differences. And then, of course, Saturn is known for its lovely system of rings, the most prominent system of rings in the solar system, mostly made out of ices, and that's why they shine so brightly, because they're reflecting sunlight. And so that's Jupiter and Saturn up in the constellation Capricornus tonight. And then we have Neptune and Uranus up in the nighttime sky, but you can't see them with the naked eye. They're too far away, too small, so we need telescopes to see them. Neptune is up in the constellation Aquarius, Uranus is up in Aries, and let's learn more about these planets themselves.
Perfect. I've got one question for
Okay.
you before we go to both of those.
Awesome.
You had mentioned before that modern astronomers just connected planets to make a dot, and we have the beautiful river flowing through the sky.
Uh-huh.
How do they know which dots or stars to connect to form these new constellations?
Um, you do. They literally are made up by whoever is drawing that catalog. And so there was an astronomer named Hevelius, and then there's Flamsteed with the different illustrations. But basically, they handmade previously and then eventually could print catalogs. And then some constellations caught on, some didn't. Some constellations were introduced and no one cared. Some constellations have changed over the years, like in the southern hemisphere in particular, there was a constellation representing Argo, Jason and the Argonauts, so the big ship, the Argo, but now it's been broken down into Vela, the sails, and the different parts, keel, the Carina, so the different parts of it. And then some constellations actually are mistakes, like they got misprinted from one constellation to another, and they're like, oops, we better just call this a new thing. So yeah, somebody had to make it up. And then in the early 1900s, the International Astronomical Union got together and said, okay, these are the shapes that we've agreed upon, the names we've agreed upon, and the boundaries. And so a constellation is not just the dots of the stars and the lines connecting them, but a region surrounding them. And so we have agreed upon 88 constellations and their boundaries that professional astronomers use. And then, of course, many cultures all over the world have their own constellations and stories, which is a lot of fun to talk about too. That is a great question.
Yeah, that we should have a talk about that. I think that will be wonderful. All
Yeah,
the different cultures of constellation.
yes. Always happy to do that. So here we have the solar system. We have the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are all to color scale and to size scale with each other. Spacing, however, not good, but color and size works. And so what you immediately notice is that Jupiter, Saturn, Uranus, and Neptune are huge. And these are often called the Jovian planets, Jovian for Jupiter. And you'll notice that Uranus and Neptune have very different colors than Jupiter and Saturn. And so they are frequently now called ice giants. So what are ice giants? Well, ice giants are not to be confused with frost giants. All right, so we do have to have a little bit of a talk about this. This is Ymir, and he was an ice giant who existed before the Asgardians and fought Odin and all that stuff. And then frost giants are direct descendants of Ymir. They probably the most popular descendant that you know of a frost giant is Loki. All right, so I gotta get this in here because nerd, right? So when we talk about ice giants in the solar system, we're not talking about these sorts of frost giants or ice giants, although some of the moons of Saturn are named after these ice giants and frost giants. So let's come back to the Jovian planets. These are those Hubble Space Telescope images of Jupiter and Saturn that I just showed you, but Hubble also recently looked at Uranus and Neptune. So I wanted to mention these to you as well, because here they are all together. And you can see from their different colorations and their different sizes, you can kind of get an idea that maybe there is something different going on with Uranus and Neptune. And because of their position in the solar system and the temperatures that they're at, and I'll give you an idea of why, they have probably incorporated material in an ice form into their planetary bodies, which is why the term ice giant has come into use for these objects. So let me give you an idea of where things are in the solar system. I showed you that those images before were to color scale and size scale, but I said the spacing didn't work. And so let's show you the solar system and the orbits of objects in the solar system more to the correct spacing. And so Jupiter is about 5 times further away from the sun than the Earth is. Saturn's about 10 times further away from the sun than the Earth is. Uranus 20 times, Neptune 30 times. So when you get to the outer part of the solar system, the distances from the sun are huge. The distances from these planets from each other are also huge. But what that also means is that it's cold out there. And so that when we take a look at temperatures out in the outer part of the solar system, it is really cold. So on this scale, Fahrenheit is on your left and Celsius is on your right. And for those of you who are looking at the graphic on the left, you'll notice that Venus is hotter than Mercury, even though it's further away. Hello, greenhouse effect, but that's a separate talk, right? So let's actually focus on the outer part of the solar system. And you will notice that temperatures out at Uranus and Neptune are negative 300, negative 400 degrees Fahrenheit. So it's really, really cold out there. And so some of the materials here on Earth that you're used to being sort of in the gas phase or in a liquid phase are comfortable in the ice phase out in this part of the solar system. And so ice giants have distinctly different interior compositions from gas giants like Jupiter and Saturn. These two objects, Uranus is on the left, Neptune is on the right, get their color actually from the amount of methane in their atmospheres. Jupiter, Saturn, Uranus, and Neptune all are mostly hydrogen and helium when we look at them in terms of the gas composition. But when we take a look at Uranus and Neptune, they have more methane in their outer layers than Jupiter and Saturn do. Methane is a good greenhouse gas, which means it absorbs infrared. It also is good at absorbing red. And the better a material is at absorbing red, that means the more it reflects back blue. And so the atmospheric composition of Uranus is about 2% methane, and then for Neptune, it's about 3% methane, which is why Neptune is a bit of a deeper blue. And when we compare the interiors of the four Jovian planets, we think they all have kind of a rocky core deep down inside of them. But whereas Jupiter and Saturn have this weird substance called a metallic hydrogen, it's highly compressed hydrogen in their centers. Uranus and Neptune have materials that are icy, like water ice, ammonia ice, methane ices. We think that are deep down in their interiors. Hence the term ice giants. And so here we have an image of the planet Uranus. Apparently one of my dogs has an opinion on this. So here we have an image of the planet Uranus taken by Voyager 2 back in 1986. Uranus and Neptune are really interesting planets, but they've only been visited by the Voyager 2 spacecraft. And so kind of a bummer that we've only seen them once. And then you might notice that Uranus is almost completely featureless. But when we take a look at it in the infrared, we can crank up some of the contrast and see deeper into basically more details in its atmosphere. And it does have some banding and some stripes as well, but in visible light, it's just like a pale blue egg. This image of Neptune was taken by the Voyager 2 spacecraft back in 1989. And that's when we realized that Neptune has a great dark spot, kind of like Jupiter has the great red spot. And then it has some high cirrus cloud, those clouds that you see there up in the sky. And so this is basically the last whole image of the planet Neptune that the Voyager 2 spacecraft got. And I think it's a shame that we haven't been able to get back out there to take a look at these planets more. Voyager 2 visited Jupiter, Saturn, Uranus, and Neptune because of where they all were in the solar system at that time. It could kind of do a flyby of all four of them, what we called the grand tour back in the day. But these planets are not actually near each other on this in the solar system anymore, even though they looked like they were near each other on the sky. And so you couldn't do the Voyager 2 grand tour with these today. So this is Uranus from October, as seen by the Hubble Space Telescope. And Uranus orbits kind of on its side. We think it probably got suffered from some sort of catastrophic impact earlier on in its history. And we're seeing sort of this bright band is the part of the polar cap, so to speak. Remember, it's gaseous, it's not an ice cap, but the part of the, I guess we call it a polar hood, that's been receiving sunlight, and you're seeing some temperature striations. And then this is the Hubble Space Telescope image of Neptune taken in September. And you'll notice this is as good as Neptune gets from the Earth as seen with the Hubble Space Telescope. So we can still see the great dark spot hanging out up there, but we lack really the ability to see the finer details like the cirrus clouds from this far away. So mostly made out of hydrogen and helium, got some ices deep down in their interiors because they're far away from the sun. It's much colder out there, and some of these materials can be ices. This is a set of images of Uranus, some of its moons and its rings, and you'll notice the moons look like they're making three little dots. That's because this is a superposition of images so that you can see the moons move. And so this is a Hubble Space Telescope image, and I like showing this because it does show you that Uranus is on its side. its rings orbit over its equator, so we can see its rings going around it in that direction, and its moons also orbit roughly in the same plane as the rings itself. And then this is a loop, an animated GIF of images taken from early November from Bradford Observatory in the UK. And the big bright dot with the diffraction spikes is Uranus. And then you're seeing some of its moons traveling with it. And they actually observed it for long enough that you could actually, they observed it for several hours, which was long enough to see some movement of the moons going around Uranus. So I thought I would show that to you because that was pretty cool. Neptune also has rings. And then this is actually a set of images from the Voyager 2 spacecraft, where that black stripe going down the middle of the image is actually trying to hide the brightness of Neptune so that we can see the rings. So the two main rings there are clearly visible and appear complete. It is not easy to notice these rings from the Earth. It's almost impossible. But these were sort of the discovery images in this case, or basically the clearest images in this case of the rings. So Uranus and Neptune have rings just like Saturn does. Jupiter does have a ring as well, although it's actually really boring. So and then like Jupiter and Saturn, Uranus and Neptune have a lot of moons. And so these are the moons of Uranus that are larger than 150 kilometers. You might notice if you look at the names Titania, Oberon, Miranda, Ariel, and so on, the moons of Uranus are named after Shakespearean characters. And so Uranus has, I'm trying to remember off the top of my head, it has over a dozen moons. And so does Neptune that we know of, and these are the largest ones. And you'll notice you're not seeing atmospheres or anything here, but you're seeing some interesting characteristics. My favorite moon of Uranus is Miranda because it looks weird. This is a messed up moon. And you're seeing all sorts of scrapes and stuff on it. And there is trying to figure out why this moon looks so weird. Couple of ideas. It could have had a collision that actually scraped. It could have been a grazing collision. Another idea is that there was more of a head-on collision that shattered the moon, and the gravity of the moon has kind of held it intact. This is a moon that I would love to go back and see more of, because when the New Horizons spacecraft got out to Pluto and took pictures of Pluto's moons, particularly Charon, it was just like, oh, there's so much interesting stuff going on out there. We want to learn about it, but these moons are closer. Maybe we could study them and it would help us figure it out. And then here are the moons of Neptune that are larger than 150 kilometers in diameter. And you'll notice that it has a very large moon called Triton. This is one of the largest moons in the solar system. It is almost identical to Pluto in size and in a lot of its observable characteristics, too. And then you'll notice some of these moons, they're kind of blurry. Remember, to get images of the moons like this, these images came from the Voyager 2 spacecraft while it was flying by really quick. It was not doing a long-term orbital mission where it could go fly around these systems and take close-up images. So for Neptune and Uranus, these images are as good as we currently have. The moons of Neptune are named after sea gods and nymphs because Neptune was a god of the sea. And so we have that thematic tie together here. Beautiful image from the Voyager 2 spacecraft of Neptune and Triton. I always like to show this one. Triton is in a retrograde orbit around Neptune, which means it is orbiting Neptune opposite the direction that Neptune rotates, indicating possibly that this could be a captured object. One of them, maybe a Kuiper Belt object that got captured by Neptune's stronger gravity. This also means it's an unstable orbit and that Triton is spiraling inward towards Neptune. And it is possible that when it gets close enough to Neptune, that the tidal forces will cause it to shatter apart, and then that debris would make rings. And so maybe if you come back and take astronomy with me in a couple 100 million years, I would be showing you the rings of Neptune as being the most prominent rings in the solar system. Now, these are the ice giants in our solar system. But this is an artist representation of what it would look like in the sky if we could see, the solar systems that are out there. We have, when we take observations of the Milky Way, statistically, it's thought that our own Milky Way galaxy may have about 100 billion planets. And with searches over the last several years, we have discovered several thousand solar systems. And when we take a look at these exoplanets, these planets that orbit around other stars, and we've tried to figure out what types of planets are they, it turns out that ocean worlds or ice giants, these sort of Neptune-like objects in terms of their size, are fairly common. How common? Well, I just went to NASA's exoplanet database yesterday to pull up the number of confirmed exoplanets, and we are at 4,575 confirmed exoplanets, so planets that orbit around stars other than the sun. And of those, it turns out that Neptune-like planets are the most common ones we find. So Uranus and Neptune had deep out in our solar system, visited only once. They might be our solar system's example of the most common types of planets in the galaxy. And so um, I might not have the best images, the most detailed images to show you because we've only been out there once, but I hope that I've given you an argument for why they are interesting places in their own right. All right. So let's see if you have any questions for me, and
Yes.
then I will stop sharing.
Wonderful. Thank you. Perfect. And I'm going to say hi to Carla real quick. Hey, Carla.
Hey, Carla.
She is taking care of recordings and live streamings on YouTube.
Excellent. Thank you, Carla.
And so we have a question for you. Did New Horizons go by either Neptune or Uranus?
They did not. Its direction towards Pluto did have a go by Jupiter, however, and it took some fantastic images of Jupiter and some of its moons as it went flying by. But its trajectory, Uranus and Neptune just weren't along that path at the time. So, yeah, the New Horizons spacecraft is the spacecraft. I shouldn't say it's the spacecraft that's furthest out because some of our older spacecraft are further out than it is, but it's the spacecraft whose object of interest was the furthest out. And so it studied Pluto and then Arrokoth, and maybe someday something else along its trajectory while its batteries last. We can hope.
What's the battery life on those again?
You know, they,
Okay.
I think the estimate, and there might be someone in the audience who knows better than me for New Horizons, if I saw correctly. But the estimate, I think, was that it should have till the mid 2020s, that it would have enough to still send back imagery and
Yeah.
stuff like that. Otherwise, these spacecraft keep going. And the reason the Voyager spacecraft just keeps saying hello to us to let us know they're still there and they can take some basic readings of like the magnetic field and stuff, but yeah, not the same level of science observations that they used to be at.
Yeah. Makes sense. I know that from all my technical devices, the batteries eventually go.
Yep.
We have more questions for you. Which is bigger, Uranus or Neptune?
So they're actually, when I talk about them in class, I tend to call them twins, almost identical in radius. Neptune's a little bit larger in mass, a little bit larger in radius, but they are very twinsies, if you want to think of them that way.
I
Um,
like that.
so think about 15-ish times the mass of the Earth and about 4 times the radius of the Earth.
Oh, wow. Yeah.
Yeah. Because I know you put them up next to Jupiter and Saturn, you're like, oh, look, babies. And it's like,
I know.
nope, they're still big. They're still
It's
plenty big.
so many bigger than us. What is the dark spot on Neptune that you showed us earlier?
All right. So that is a large storm. It is larger than the Earth. And much like on Jupiter, excuse me, yeah, on Jupiter, it is long lived. We first noticed it in 89 when we passed by Jupiter or when we passed by Neptune with the Voyager 2 spacecraft. But it is interesting because it is just what we think of as a long-lived storm system. It's a long-lived cyclonic wind pattern
Mhm.
in the storm system. Oh, wait, I just saw Jason Cook pitch
Yeah.
in that we expect New Horizons to last till maybe the mid 2030s. Thank you, Jason. I
Thank
appreciate that.
you.
That is a scientist from the New Horizons team
Yay,
speaking up
Jason.
there for us. Thank you, Jason.
Thanks for being here. Perfect. I have a question in the chat also. What is the definition of a super Earth from the last graphic you showed us?
So, um, it's a planet whose mass is bigger than Earth, but less than Uranus and Neptune. It kind of falls in there. I've seen some definitions where it has to be solid, some definitions where it could be gaseous, but I think most people try to think of it as a significantly larger terrestrial planet. But some of these, how shall I put this? Some of
Hmm.
these definitions slide around more
Okay.
than I personally would be comfortable with, simply because these are objects that if we studied our own solar system, we didn't know they existed. And so when we discover them, we have to give labels to them. And then as we learn more from follow-up observations, say we discover we get transit data, so we get a sense of their radius and not just their mass and stuff like that. Then we can start to get densities, and some of the things that we thought were gaseous might be solid, and vice versa. So it actually kind of slides around a bit. But yes, so think of them as significantly larger than the Earth, but not as large as Uranus and Neptune.
Okay. And to go back to that black spot on Uranus, you said it's bigger than the Earth. Do you know how much bigger
Um,
it might be?
for that one, it would be like Earthish.
Okay, Earthish.
Yeah. Yeah, because the radius of the world itself is only about 4 times the radius of the Earth,
Mhm.
and so it's about Earthish in size.
Thank you. And do we have images of Betelgeuse?
So, so we do have images of Betelgeuse. Our best ones, so stars are also far away that we can't get really detailed images of them. So what we see for Betelgeuse is a blob. It's a reddish blob with sort of bright spots, and you can kind of tell, like, just like our sun has a corona and coronal mass ejections and stuff, we can see those sort of features around Betelgeuse itself, but nothing in a lot of nothing that allows us to see it in a lot of detail, except from the standpoint that astronomers are like, oh, look, that's detail because we can
Yeah.
see blobs on
Yes.
it. But yeah, all stars are so far away that they should be just little pinpoints of light. The spikes that you see on the stars behind me in this background, that's actually because they're overexposed. You're getting the diffraction spikes because they're so bright. And so lots of what we think of as being the size of stars in an image is actually just capturing how bright it is. And the brighter it is, it looks bigger in the images.
Got it. That makes sense. At least something makes sense to me once in a while. I'm always the ones to ask some question like, hey, just, give it to me again. I can't quite wrap my head around it. We have another question. Is there a scientific reason for using the word Andromeda for the title of the book movie Andromeda Strain, or just creative writing? Do you know?
I don't know because I have not read that book. That's Crichton, right? That's Michael Crichton, if I recall correctly. I never read that, so I don't know if the writer had a reason to call it the Andromeda Strain, or if he just liked the sound of it.
Probably. I mean, could very well be.
Well, first, it's always going to in part be because they like the sound of it, but sometimes they come up with a justification, and I don't know if there is an in-world or in-story justification for it or not.
Yeah. What I would
Interesting
like to
question.
know, since modern astronomer were able to name constellations, and is there room for you to name a constellation for the Fleet Science Center.
I am sorry. I have a feeling that the International Astronomical Union might not do that. There are rules and conventions for the namings of things because
Oh,
you heard me right. I said like the moons of Uranus are named after Shakespearean characters, the
exactly.
moons of Neptune.
Yes.
There are naming conventions for
Okay.
things. And so I don't think naming after fantastic science museums is one of their naming conventions. We can try.
We should suggest it. I mean, we have a triangle. Should be easy to find 3 stars that we can put
Well,
into a triangle.
we'll just keep having to make sure that every time NASA launches something with a plaque with a bunch of names on it or something like that, we'll keep putting it there.
Yes, perfect. I love that. We have another question for you. Is it possible that Orion and other constellations also have planets not bright enough to see due to distance?
Oh, that's a great question. We actually think that stars, planetary systems are common. That's going to be the idea, right? In our surveys, we've only seen, oh, only, I say now, only seen about, over a little over 4,000, which is funny because when I first started teaching astronomy, and certainly when I was in astronomy classes in college, we hadn't seen any outside our solar system. So it's amazing to me still that we see this many. Um, Planetary systems around other stars are hard to find. First of all, planets in our own solar system, when we look at them in visible light, we see them shine by reflected sunlight. And so, what the easiest thing is to always detect is the light from the star, not the light from the planet. So, direct observations of the planets are very difficult to do. We're actually hoping that the JWST will actually be able to do some direct observations of planetary atmospheres. So the means by which we discover planets most of the time involve the planet's effect on the star, whether or not it makes the star wobble due to their gravitational interaction, or if it covers some of the light and we see changes in brightness. Um, and so all of those are hard to do. And the star's brightness is what we need to in many ways to overcome if we want to see the planet itself. So um, we know that there's star forming regions in Orion, and then Orion has older, more mature stars, and those older, more mature stars very likely have planetary systems around them.
Thank you. So we're just tiny little bit over time, but I want to be mindful of that. And we have 3 more questions. So I say we're
I'll
going
take
to
them.
answer these and then we'll close it out.
Okay.
Since Uranus is tilted by so much, does it experience extreme seasons?
It does actually, because of its tilt and its long journey around the sun. It takes 84 years to go around the sun once, to orbit the sun once. So you have places on Uranus that have 42 years of darkness and 42 years of daylight. And so you do get some extreme variations in that way. But what Uranus lacks compared to the other Jovian planets is a strong internal heat source of like its temperature is different, shows different patterns than Jupiter, Saturn, and Neptune do. Um, so what we see though is like you saw in that sort of cloud banding in the infrared is that whatever pole is facing the sun during that time is definitely warmer. You do see those temperature variations, and it would be extreme by if you counted by latitude.
Yeah.
But we don't see storms really the way we did. Oh, hey, you had somebody ask you if you're going to do the survey.
Oh, Jesus, that's right. Whoops. Mrs. Decker was not ready for a survey
I
on that
know.
short notice.
All right. So I will, while you're looking for the survey, I will answer. Let's see. I
That
see
sounds
Mary
great.
has a
You do
question.
that.
All right. Regarding Comet Littered, I've heard that it might become naked eye in December or January. Any thoughts? All right. So there is a comet that is showing some promise to become a naked eye comet. I tend, okay, with comets, I tend to believe it when I see it. There have been lots of comets that have let us down over the years, or have become much brighter than we thought. So if anything becomes settled for this comet, I was actually looking at that today. I was looking at Twitter for some of the people who I trust on whether or not they think this comet is going to be naked eye, and I think we're still in the jury's still out phase. But
Okay.
hopefully we'll be able to see it. And then I see how do you know what areas of deep space to search for exoplanets? So That's an interesting question because when we show distribution of exoplanets on the sky, you will see a ton of them in the constellation Cygnus. That's just because the Kepler spacecraft pointed at Cygnus for most of its lifetime and did deep surveys there to look for transits, that dimming of the brightness of a star by a planet passing in front of it. That doesn't mean that they're more common in Cygnus. That's sort of what we would call an observational bias. We had an experiment that was focused on that one area of the sky. And that's part of what you have to do based on what your goals for the experiment were. So what the Kepler spacecraft did for the majority of its life was, or for its initial mission, was it looked in the constellation Cygnus and it looked at particularly stars that are similar in type to the sun, so that they could see if solar systems like our own were common, like where we're going to find a bunch of Earths, Jovian planets on the outside, terrestrial planets on the inside. So we were looking for those similarities. And so that was the choice that they made when they designed that mission. But then it says, then it's kind of fun when we do put the software up on the dome, because it make it look like all of the planets are right there in that one
Yeah.
constellation. So you do have to make a choice to fit your experiment. So but then you have to be aware of how that affects your data. So the answer is we don't know what areas necessarily to look at. We have to pick areas and see if they're representative.
Not easy.
Not
To balance
easy.
that all out, right?
Yeah, and to me, it's one of the interesting things because it does remind us that there is always observation, what we call observation, what astronomers or what scientists call observational bias, is that we have to look at the experiment that we performed and recognize, oh, it's more likely to find this sort of thing, and then understand that when we interpret the data.
Yeah.
That's important.
All right.
Um,
One
I,
question. The
uh-huh.
last question of tonight. Was there ever proof that aliens exist?
There has never been definitive proof that aliens existed, because that would be so awesome.
Yeah,
That would be
Lisa and
so
I
awesome. I
both
would tell you
wait
about it.
for that, don't we?
Yes. Yes.
I'm also waiting for a moon called Loki.
There is. I don't think there is one. I
See,
should
should
look.
be though, right? Since he's
I'll
one of the
look.
ice giants, I think there should be.
I will definitely look.
Thank you so much, Lisa, for a wonderful presentation. Again, I just love spending time with you and learning all about this. And I'm so glad that everybody else was able to join us tonight.
Yes.
Thank you for the questions, for your engagement, for the thank yous that we've gotten. We really appreciate all of you being here, your support, your interest, because without you, we would not be here, we would not be doing what we're doing. And we hope that we can continue to engage you with the various opportunities that we have through the
Yes.
Science Center.
Absolutely. Absolutely. Thank you so much. And thanks to those of you who came to see us at Comic-Con Special Edition this weekend as well. It was wonderful to see some of you in person for the first time in a long time.
Yes, thank you so much. And do come visit us. We're open through the holidays. We're one of the institutions that's open 365 days a year, unless there's a pandemic, then we are not. But since that seems to be fairly under control, we've been open since April, and we hope to continue like that. And we hope to see you soon, or at least sometime next year. Thank you so much for joining us, and have a wonderful evening, everybody, and happy holiday season to all.
Right.
Bye.
Good night.